Welcome everyone to the Casco Bay Coastal Academy workshop, Climate Change and Drinking Water, Challenges and Opportunities for Private Wells and Small Water Systems in the Coastal Zone. This is part one of a two-part series. Today is focused a little more on understanding the issues and how climate change is or will be impacting drinking water. Part two on the 22nd will be a little more focused on solutions, so technical assistance and funding. I wanted to mention that we are recording this session. Hopefully everyone's okay with that. And can everyone hear me okay and see the screen okay? Great. Well, first of all, I wanted to express some gratitude and thank everyone for being here. Our communities have been devastated along the coast in the last couple of weeks. And it's very impressive that folks are showing up and thinking about doing some of this long-range planning while also, cleaning up and doing storm recovery after the coastal events. So the fact that you're here means a lot. So thank you for joining us. For those who aren't familiar with Casco Bay Coastal Academy, I just wanted to talk a little bit about what we are. We have a quarterly workshop series organized by multiple organizations, and the aim is to build the knowledge base of critical coastal issues for municipal board members and staff, and also some skills training to support project planning and implementation. But we have folks from state, federal, government, nonprofits, and others. So it makes for very rich discussions for our series. I'll introduce myself. My name is Victoria Boundy, and I'm with Casco Bay Estuary Partnership. We're part of the National Estuary Program, and we have a small staff that works to provide technical assistance, funding, and scientific information to protect and restore Casco Bay. And I'd like to invite my co-organizers to introduce themselves. Chloe?
Hi, everyone. I'm Chloe Shields. I'm the Deputy Director at the New England Environmental Finance Center. We work to build community capacity to sustainably fund and finance environmental priorities, and we work across New England, based at the University of Southern Maine in Portland. I'll hand it to Gabe.
Thanks, Chloe. Thanks, Victoria. Hi, everyone. I'm Gabe McPhail. I'm the manager for R1CC, or the Region 1 Coordinator Collaborative, which is the collaborative group that serves York, Cumberland, Saginaw, Lincoln, Knox, and Southern Oxford County, serving as regional coordinators for the Community Resilience Partnership.
Hey, thank you, Chloe and Gabe. Let me go over some brief housekeeping items. We're all familiar with this now, being on Zoom for a while, but given that it's a pretty large group, it's worth reminding. So if you haven't already, you can put your name and affiliation next to your lovely faces, introduce yourselves in the chat, and please make sure you're muted if you're not speaking, to cut down on any background noise. We will have a dedicated Q&A time, so I'd like to invite you, while you're listening to the presenters, to jot down any questions you have. You can either put them in the chat, or we'll utilize the raise hand feature when we get to that stage. So just a little bit of housekeeping, and now I'll briefly go over the agenda for the program. We have an hour, so it's very quick. We're going to spend the first 15 minutes to hear from some island communities about what they've done to begin tackling drinking water challenges. How did they identify this as an issue, and what are some of the steps they've taken so far? We will then move into hearing from Ryan Gordon, who's hydrogeologist for Maine Geological Survey. He'll provide more of a scientific and technical background on exactly what the issues are, how climate change is impacting the water cycle, and what are the implications on drinking water. From there, we'll move into a rapid fire 10-minute Q&A period and discussion. And then we will close out by talking about follow-up resources and our second session that we have planned. The program officially ends at 1, but we will be staying on along with some of our presenters until 1:15 to answer more questions and have more discussion. So that's what our agenda looks like. So let's move right into it. I'd like to start with, we have 3 community presentations. Each of the 3 presenters will have about 5 minutes. And we're going to begin by hearing from Richard Tucker. Richard is the chair of the Conservation Commission for Westport Island, and he's going to tell us a little bit about steps that Westport Island have taken. So,
sure. For those of you who don't know, Westport Island is located in mid-coast Maine in Sheepscot Bay. The town has 720 year-round residents and experience an influx of seasonal residents during the summer months. The island is about 10 miles long, 2 miles wide, and at its widest point. A large percentage of the homes are concentrated along the shore. All residents in the town island are dependent on groundwater for the sole source of drinking water. No public water supply is available within the town. Consequently, residents are dependent on individual wells for their household water supply. Westport Island groundwater did a study of the groundwater this year. And we did this through the Community Resilience Partnership. In spring 2022, we learned about the Community Resilience Partnership. And in September 2022, Westport Island joined the partnership. We first had to complete a self-assessment, and then we held a workshop to review the assessment and priorities for potential projects under this program. The workshop and self-assessment revealed Westport Island's residents, as well as the town administrators, had significant concerns regarding the availability and sustainability of the groundwater resource on the island. These concerns was exacerbated by a significant drought that occurred during the summer of 2022, which resulted in reports of dry wells and/or degraded water quality. These concerns have recently been increased due to development pressure, as well as the potential of further subdivision of existing lots, which may soon be permitted. In September 2022, we applied for a grant for the project titled Planning for Groundwater During Climate Change on Westport Island. December 19th, 2022, we were awarded a grant of $48,500 to undertake the study. In the spring of 2023, we held an informational meeting at our town hall to explain the study and mailed all residents a questionnaire regarding their experience concerns regarding their water supply. From the respondents received, we learned that 60% of the residents had experienced periodic dry wells, 47% have water quality issues that have usually required some kind of treatment, and unfortunately, 14% of our residents indicate that they cannot drink their well water. In the summer and fall of 2023, we completed an island-wide well water testing program where residents would have the opportunity to have the well water tested free of charge. Water from 166 wells were tested for bacteria and other contaminants. Each resident was provided with a written report on their well water quality. Where significant bacterial quality issues were found, each property owner was individually briefed and counseled on corrective actions to take. The well survey and water testing program were very successful, obtaining important data on well characteristics and increasing community knowledge and engagement about water quality in town. The offer of free water tests and sampling assistance made it possible for anyone to participate, and many elderly residents participated who would not have otherwise had tested the water. Construction of a well geodatabase was initiated late last year and is about 80% complete. The task is expected to be completed early this year. Remaining tasks include linking the well data from the Maine Geological Survey database, as well as well data collected in a former island groundwater study that was done in 2000. With the 2023 data and cleaning the data set up to remove duplicates and erroneous data. The most current GIS coverage of geologic, land cover, and topographic, hydrologic, and recharge characteristics for the project have been acquired from various federal and state agencies. Once the new geo database has completed, a hydrogeologic analysis will be conducted. So that's the current status.
That's a lot. Thank you. Thank you so much, Richard, for giving us that overview. Next, we'll hear from Chebeague Island. And speaking to the steps that Chebeague Island has taken, we have Carol White. Carol is a select board member and climate committee liaison for Chebeague Island. Carol.
Hi, Chebeague Island is pretty much in the center of Casco Bay. It's the largest island in Casco Bay, and as similar to Westport Island, everyone on the island is dependent on water wells for their water supply. And Chebeague's had a long history of doing various groundwater studies over time. The first one being back in the 1980s. That data was used to come up with minimum lot sizes on the island based on recharge characteristics. And then we've done a number of studies looking at issues of salt water intrusion and septic system related contamination, funded by DEP grants, funded by EPA grants. And then most recently, similar to Westport Island, we've initiated a groundwater study, sort of a sustainability study with the through the Climate Resiliency Partnership grant program. We're using a portion of our community action grant to pay for an update to our groundwater data set. And because I've had experience with a number of these studies on various, mostly coastal communities in Maine, I just thought I'd cover what typically are the basic steps that we go through in these types of studies. And one of the first steps is really, I guess to give you some context, one thing is the geology of these towns is very important and unique. And the study really needs to incorporate site-specific geology in order to really evaluate the sustainability of the aquifer. And particularly in coastal communities that are using fractured bedrock aquifers, most of these often are sole source aquifers, which means that the precipitation that falls on the aquifer is the sole source, and the amount that recharges into the aquifer is the sole source of groundwater or drinking water for the community. And so the specific soil characteristics, fracture characteristics, bedrock characteristics really have a significant amount of control on what the groundwater availability is. And typically in these studies, we did a number of these studies back in the late 80s, early 90s, up through 2000, mostly funded by State Planning Office grants. And Harpswell participated in those studies, a number of the other islands. And those studies basically had a well data collection component, a water sampling component, sort of an analysis component looking at recharge characteristics. And in some cases, we incorporated a groundwater modeling component. 6 steps that you go through to kind of complete these studies. And sometimes you can go on to a more sophisticated step at the end to do more, regional groundwater modeling to look at sustainability questions. The studies back in the 80s to 90s and early 2000s were pretty comprehensive, but at the same time, our understanding of the geology has improved, and there have been a number of new wells that have been completed since that time. So at least for Chebeague, we're updating that data set. We also completed a community-wide groundwater sampling program and had very good participation. And part of that purpose of that program was to identify areas where saltwater intrusion is occurring, or to find out about new areas that are occurring. We're aware of probably 5 areas on the island where there's significant saltwater intrusion right now. And then the next step will be to do some analysis to compare recharge characteristics, precipitation, and sort of future climate scenarios to kind of evaluate the sustainability of the aquifer. I guess the last thing I just wanted to say under Shabig's part is we have been remiss in the past, myself especially, since I'm a hydrogeologist by trade, in really going the next step to taking some action to protect our groundwater resources. And so I'm on a mission this time to really, implement some action items to protect the aquifer. And there's multiple different ways that you can do that, lots of different strategies that are being used here in the United States and in Canada that could be applied to these kinds of problems. I'd be happy to talk about those in the Q&A. So I think I'll leave it at that. And if anybody has any questions specifically about Shabig, I can answer them during the question and answer.
Thank you. Thank you so much, Carol, for a lot of good information in a short period of time. Reminder for people to put their questions in the chat for any of these presenters. We're going to round out the community water stories and hear from Long Island this time. And our speaker is Janice Avignon. I hope I pronounced your name correctly. Janice is on the Comprehensive Plan Committee. She's Comprehensive Plan Committee Chair. So Janice, thanks, and take it away.
Sure. So, and I am a citizen, so I definitely am not a hydrologist by trade and no domain expertise in this, but certainly water came up in our comprehensive plan process and all of the community engagement as the #1 concern. So as we went through a 2-year, if anyone's gone through the comprehensive plan process, it really is a 2-year process where that the community participates in. And so we did lots of community engagement, including workshops and sessions and surveys. So now, although anecdotally, I would say that water's always been a concern. For those that may not know, we were a refueling station in World War II. So there were a lot of activities that happened during that time that really concerned people about the water supply. There was a big oil spill in the 1970s on our shore. So that was also a big concern, in addition to just the basics of we're on ledge, we're a single source aquifer, we're in the middle of Casco Bay. So, on top of just our general concerns, it's always been anecdotally part of the conversation. But as part of the comprehensive plan, we could validate and quantify the fact that for all of the population, seasonal, year-round, all ages, universally, the water supply was the biggest challenge that people saw to sustaining our year-round population as a unbridged island. So steps as part of the discovery during the comprehensive plan and recommendations coming out of the comprehensive plan included actually coming up with a groundwater quality committee that's sanctioned and approved by the select board and was given a budget and a charter. We also enrolled in the Community Resilience Partnership and applied for a grant to do a similar study to what was discussed by Richard and Carol. We are extremely fortunate, and Carol is our neighbor and neighboring islands, so leaned heavily on the work that Shabig had done to write the grant that we were recently awarded to do a similar water sustainability study. So we're just starting out on that, but there is some field work that started to do the steps that Carol outlined around well inventory, water testing, and we were fortunate also to be able to get a resilience fellow that's going to help us with capacity to actually execute some of the work in the grant. So we're up and running, but kind of running behind the other communities that you just heard from.
Thank you, Janice. Doesn't sound like you're running behind. Well, that closes out our community presentations. Hopefully that will give other communities present on the call some ideas for tools and how to get started, and for service providers, give you a sense of what those community concerns are. Our next speaker is Ryan Gordon, hydrogeologist for Maine Geological Survey. And Ryan's going to tell us about, the science of how climate change is impacting the water cycle and what some of the implications are for drinking water in coastal Maine. Ryan, I think you've got your presentation ready to share.
Yes, is it showing now?
It is.
Great. So I will just take it away then. So thank you to all the hosts for inviting me for this. It's great to talk to you all. So I'm a geologist by training. I work for the Maine Geological Survey, which is part of state government in the Department of Agriculture, Conservation, and Forestry. And I specifically study water and the water cycle, so that makes me a hydrogeologist. And I'll be talking about Maine's changing hydrologic cycle and how climate variability specifically impacts drinking water. And I think I have 20 minutes to do it, so it's going to be a kind of a whirlwind here. So, but I'm happy to take more questions later on, and I'll stay on after 1 o'clock too, so we can talk in more detail about any of this. So some of the topics I'm going to cover briefly are Maine's drinking water, just how we use it and the sources we have in the state, and then dive right into the climate change and variability in the water cycle. I'll briefly touch on sea level rise. There's a lot more I can say than what I have here, though. And then at the very end, if there's time, I'll mention a case study from Monhegan Island. So just some kind of basic facts about drinking water in Maine. It's just about 50-50 split among residents. 50% are on public water, get their water through utilities, and 50% use private wells that are, located on their own property in their backyards. Wells and lakes are the two main sources of water, and that's fairly evenly split as well between groundwater and surface water. Some other systems use streams and rivers, and then there's many wells that are actually located close to large stem rivers where the river water has some impact. But generally it's about, fairly evenly split between groundwater from wells and surface water bodies. So on the right-hand side here, I have a little plot just showing water use in Maine. So this is annual water consumption by various sectors. It averages about 140 billion gallons per year in Maine. And you can see like a lot of that is industry. This is both surface water and surface water and groundwater. If we're just talking about potable water withdrawals, that can be considered drinking water. These two top categories, private homeowners and public utilities. So when you add those together, that's about 42 billion gallons per year, which is about 30% of all human use in Maine. And then if we're just to look at groundwater specifically, potable water withdrawals are about 22 billion gallons per year. And that's a higher percentage of all human groundwater use. So 70% of the groundwater used in Maine by people is for potable drinking water. So where does this water come from? For all the water resources in the state of Maine, it all begins with precipitation that falls, relatively locally near the place where it's being extracted. So it's not from faraway places. It's not stored from millions of years ago. It's really precipitation that's falling on an annual basis on the ground around where we live. And Maine is very rich in water, so we're very lucky compared to a lot of other parts of the country. We receive a lot of precipitation. So the only pretty much wetter parts are the southeast and the Gulf Coast, and then high elevation and coastal areas in the western mountains and the west coast. That said, the amount of precipitation does vary a lot around the state of Maine. So I have up here 45 inches per year is the average over our land area and over many years, but there's really a lot of variability in both space and time. So over here we see we can get on average less than 40 inches up in Aroostook County and more than 60 inches on parts of the coast or in the high elevations. But if you take that average of 45 inches per year, that's 26 trillion gallons of water every year falling on the state, which is a lot of water. It's too much to comprehend, really. What happens to that water when it hits the ground as precipitation? So very briefly, this is like high school textbook water cycle stuff, but I just wanted to talk about kind of the fate of some of these drops of water. So what precipitation falls on the land surface, about 50% of that runs off pretty quickly into streams and rivers and into the ocean. So half of that is surface runoff. And then about 35% is lost to the atmosphere through evaporation and transpiration. That's the use of water through plants, which is a very large part of the water cycle, actually. And that leaves about 15% left to infiltrate into the ground, where turns into our groundwater resources and flows through aquifers. It doesn't just stay in aquifers, it's moving all the time. And it eventually discharges into rivers, streams, lakes, and ultimately the ocean as well. So what are those, the most mysterious part of this really is the groundwater component, because it's beneath our feet and we can't see what's going on. So I just wanted to briefly touch on the types of aquifers that we have in Maine and how people access that groundwater. So underlying all of the land area of Maine is the bedrock, the fractured crystalline bedrock aquifer is the way we refer to it. But it's solid rock that has fractures in it, fractures that do intersect the surface and so get filled with water and can transmit water in kind of a crazy sometimes network of these interconnected fractures, which are shown as lines in this cutaway diagram, but are really plain, and so have a really complicated three-dimensional geometry. Most private wells in Maine are drilled into the bedrock aquifer. So here, if you can see my mouse, I don't know if you can see my mouse as it goes around, but this drilled bedrock well is going through whatever surface materials are here and into the bedrock where it intersects some of these fractures. On top of the bedrock, and not all of Maine, but in parts of Maine, are a variety of different surficial materials, or you could call them soils. Fill is a very common one that was laid down by the glacier. It covers both uplands and lowlands in Maine and is a water source for a lot of folks, especially that have older dug wells on farmsteads, but they are still often quite used. So up here in the upper left is an example of a dug well dug into the Till aquifer where water levels are pretty shallow. So water's close to the surface. And then in some areas of Maine, typically in valleys, there's more of a kind of a package of sediment that was laid down by the last glacier. The most important of this is the sand and gravel aquifers, which are here in yellow. Those are excellent aquifers in that they can hold a lot of water and transmit a lot of water to wells that are drilled into them. So a lot of municipalities that have wells, they look for these sand and gravel aquifers. Industry uses them, irrigators use them. Anybody who needs a large amount of water is going to be looking for sand and gravel areas to get their water. But just to kind of picture what these look like, I have a couple of photos on the left-hand side. On the bottom is like a typical road cut that you might see on the interstate, where you can see, especially in the winter when it freezes, water that's moving through fractures in the rock. And then up above is a sand pit that was dug into an esker ridge. So it's very much like this yellow ridge that I have in the diagram. But it's an esker. It's composed of sand and gravel, and those make really excellent aquifers. But like I said, those sand and gravel doesn't occur everywhere in Maine. In fact, it's kind of distributed in these finger-like patterns throughout the state, really confined mostly to stream valleys, those eskers that I was talking about, and then glacial fans and deltas and outwash plains. There's a big collection of them in the south, then part of Maine, and then down east as well. But you'll notice from this, so green is where there are sand and gravel aquifers, but you'll notice from this map that there aren't a lot on the coast. So especially the central coast of Maine and most of these islands and narrow peninsulas don't have a lot of this sand and gravel, which is why island communities we typically hear, and we just heard from 3 of them, homeowners are really relying on the bedrock aquifer for their water. Okay, so to jump into the climate change and variability. So we all think of, I think, temperature increases when we think about climate change. We all know that temperatures globally are increasing, and they are here in Maine as well. So the historic record in this plot on the upper right shows that temperatures increased about 0.5 degree per decade, 0.5 degree Fahrenheit per decade, going back to 1900. And that's definitely accentuating and accelerating these last few years. And then on the lower right, we have kind of a prediction of temperature change over the next 100 years. So the upper part was the historic, this is a projection of the future. And it's broken up into the 4 seasons, winter, spring, summer, fall, and then 3 regions of Maine. So blue is northern, and red is interior, southern, and green is coastal. You can see from this that it's predicted that temperature increases will be greatest in northern Maine, and least on the coast in all 4 seasons. But also all 3 regions are going to see the largest temperature change in the winter months. That's kind of a theme of what we're expecting in climate change, that it'll really be focused on in the winter time. So how does increasing temperature directly affect the hydrologic cycle? First, we're definitely going to get longer growing seasons. That means more plant life and more transpiration. So that's why I say more evapotranspiration here. That'll be a bigger component of the water cycle. Definitely less winter snow storage. So there'll be more melting of snow during the season and less in the springtime. Earlier spring ice out in lakes and rivers. And all of this leads to kind of earlier and more unpredictable river flows. So we've definitely seen that over the last month here in Maine with kind of what historically would have been unexpected floods in the middle of the winter time. That goes right along with more runoff events during winter, so small and large ones, and less frozen soil. So those are just some of the effects of increasing temperature. Then increasing precipitation. So it might not be quite as well known that Maine is getting wetter on average with climate change, and we're expecting that to continue. So we've seen about 1 inch, I mentioned at the beginning, we get 45 inches per year. That's actually a moving target. So I have to keep updating that number as time goes on because we're gaining about 1 inch of precipitation per decade. At least that's what we have been so far. And so on the upper right is the historical record averaged over Maine. You see that it's going up as we go onward in time, but it's also getting more variable. So even though we're getting more precipitation on average, we've had these periods, some of the driest periods were right around 2000, and also some of the wettest periods, like in the late aughts. So both of those things are happening. When we're looking out 100 years in the lower right here, we see that again, northern Maine is going to have more of a change than coastal Maine. And again, the winter is going to have the largest increase in precipitation, while summer is pretty much not going to change very much at all. At least that's the prediction. So how does increasing precipitation is obviously going to change the water cycle, especially in the fall, winter, and spring. So we'll have higher stream flows during those seasons. On average, more saturated soil, which means larger and more frequent runoff events, so more kind of flash flooding. Higher groundwater levels on average in wells. But I really want to focus the greater variability in time. So we're seeing an increase on average, but there's going to be more variability in time and in space as well. So we've already observed that. This is kind of old data at this point from 2014 or earlier, observing an increase in heavy precipitation events. We've definitely seen that this year. It's an anecdote, but this has happened over time as well. So across the whole country, except for Hawaii, but the Northeast has really seen the greatest increase in heavy precipitation events. And then we also have the opposite of that, drought. So short-term droughts have definitely affected Maine quite recently. These stress agriculture and drinking water and ecosystems and increase fire danger. So a lot of different human components are affected when we get into these droughts. On the right-hand side, I'm just showing a few historic droughts and some of the variables there, how long they lasted. So the median is about 12 months or a year. Some last much longer. Obviously, the longer they last, the greater the precipitation departure, or how much water we're lacking compared to the average. So we can see 2016 within there as a fairly decent drought. We've had some others in 2020, 2021, 2022 were also very dry years, but they're not as bad as some of the historic droughts that we've had. However, we think that the severity of these short-term droughts may increase with climate change, especially due to the higher temperatures and longer growing seasons. And then some climate predictions suggest that droughts may become more common as well as more severe. So this is just a kind of a little timeline of recent droughts back to 2000, where the hotter colors represent more extreme drought. And then the percentages on this y-axis are the amount of land area of Maine that's been affected by the droughts. So we have maps of this as well that show the distribution over space, but I didn't have time to include those. But anyway, we see these quite severe droughts that we had around, there was actually some in 99, but then 2001 to 2003. was very droughty, and we actually learned a lot about managing water and drinking water during that time. This big blank space is the very wet time period. That's obviously not shown here, but we saw in the precipitation record. And then we had some shorter term but very severe droughts for parts of the state in 2016 and then 2020 through 2022. Yeah, so I'm just showing this precipitation trend again to kind of point out the really dry period in around 2000 and then the wet period that followed. Obviously, droughts are they're going to be highly correlated. They are caused by precipitation deficits, so they're going to go right along with this type of variability. So what are some of the impacts of variability in the water cycle? So first, these are just bullet points about water quality. So dry periods that are followed by rain events, this can really increase polluted runoff and groundwater discharge because the water will carry a larger than normal load of pollutants. The reasons for this are that soil and vegetation are dry and more susceptible to being eroded after a period of drought. And then the pollutants and septic effluent can accumulate on and in the soil when it's unsaturated during the drought, and then they get washed out when you do get a sudden rainfall event. So these kind of water quality concerns really impact surface water more than groundwater, but it has impacts on both. And then some of the more frequent and larger runoff events that can occur with high precipitation can increase erosion and nutrient loads in surface water. So again, pushing things off the landscape, eroding them and putting them into surface water. That can lead to eutrophication, which we've definitely encountered in Maine. That's too much nutrient or too many nutrients in the surface water, which leads to algal blooms. We can also get algal blooms that are associated with drought because low surface water and high air temperatures will lead to higher water temperatures, lower dissolved oxygen, which is bad for fish and macroinvertebrates and other aquatic organisms, and can also lead to more algal blooms. And then I wanted to have an entire slide just to point out that road salt is a big ongoing and emerging concern that is tied in with climate change as well. Because as we see more precipitation events that are combined with warmer or mixed winter temperatures, we get more of these storms with mixed precipitation, and that is leading and will lead to increasing road salt use. So I think road salt, it's not a new contaminant, but it's continuing to increase. And I think is one of the larger concerns with water quality. It impacts groundwater and surface water both. So that's definitely something to keep our eyes on in the future. And then there's the more obvious impacts of variability on surface water quantity. We've had both drought and flood recently. So I just threw up a couple of historic photos here to kind of show the impacts. Drought in surface water can really impact drinking water sources that are in surface water, and floods can as well because they decrease the water quality. And then finally, the impacts of variability on groundwater level in wells. So I wanted to just talk very briefly about the annual cycle of water levels in wells. So this is an example of data from a monitoring well down in Sanford in the sand plain there. The black triangles are the monthly median over the whole record. So this kind of shows what happens on average over the year. So starting in June, water levels are relatively high in the spring and early summer, and they drop throughout the growing season, and then increase after plants die off and evapotranspiration is lower. And we get recharge events in the fall and winter, especially in southern Maine. But especially in the springtime. And so in the spring, we see groundwater levels on average going up again. So the black triangles are the medians, and then these colored bars are expressing normal in green or above normal in blue colors and below normal in the redder colors. And then over that, we have the actual data from 2022 to 2023 in as well. Those are these red diamonds. We can see like in that summer of 2022, which was a very dry one, the well was below normal for most of that year. And then when rains eventually came in the late fall and winter, levels kind of jumped up into the normal level, and then we're even above normal into that spring. So that's just an example of a single year, how precipitation and the water cycle impacts groundwater levels. And then when I wanted to zoom out and show you the whole record, the historic record of that exact same well. So you can see in this record that annual cycle is repeated over and over again of higher water levels in the spring, lowest water levels in the fall, on average. But then the whole record does move up and down with these generally wetter and drier periods in Maine. So around 2001, we have lower water levels during that droughty time. In the late aughts, significantly higher water levels, but that annual cycle is still there in the entire record. And then I wanted to show, that was just one record here. These are all of the USGS monitoring wells in Maine. So this is kind of like the bird's eye view of what's going on in water level data. So I wanted to show this. All of these are plotted on the same scale, time scale, and depth. And I think it really illustrates how water levels in Maine are relatively very stable. So in all of these records, you see the annual up and down cycle, but over time, they're quite stable. So we're not mining groundwater in Maine. We're not significantly losing water or gaining water. It's really hard to pick out any long-term signals in any of these wells. So kind of on average, our water supply in the groundwater is quite steady. Okay, and then I have, 0 minutes to talk about sea level rise, but we can continue to talk about that afterwards. I've given other talks that focus more on the sea level rise component and saltwater intrusion, but I have to go quite quickly here. So I just wanted to briefly mention how saltwater and freshwater interact at the coast. Underneath the land surface, obviously we have fresh water. It's recharging from precipitation like we talked about, and then moving outwards towards the ocean. That's these arrows here. Under the sea, the ocean, it shouldn't be surprising that the groundwater is salty. But at some point near the coastline, there's a transition zone or an interface, we call it, between the saltwater and the freshwater. It slopes downwards and inland from the coast. That's because saltwater is more dense than freshwater. So the freshwater kind of floats on top of it. And where this transition zone is, where the interface is very important for wells that are drilled into the freshwater. So what happens when you kind of perturb the system by raising sea level? How does that affect the balance between saltwater and freshwater here? Well, obviously, I have little red arrows that pop up here. Obviously, if the ocean comes up, that's going to flood the near shore. That's the most obvious impact that we have. But it also increases the pressure on the seabed itself, which has impacts in the groundwater system. That makes the saltwater interface move inland and upwards slightly. And that in turn actually can help raise the freshwater table. That effect is greatest closer to the coast and less farther from the coast. But this freshwater table can rise along with sea level due to this pressure pushing through the system. So these diagrams here are a little too complicated to explain very much, but I wanted to mention a couple different processes that can impact the saltwater interface. So just pumping or drought, anything that lowers the freshwater table and lower the freshwater table around that well. So this is a diagram of a well here in the water table. And that can also shift the saltwater interface inland. So pumping itself can change the saltwater interface. And then sea level rise, as I already mentioned, can shift that saltwater interface inland and raise the fresh groundwater table and flood the near shore and erode the near shore. So to kind of summarize the threats to infrastructure from this, from seawater intrusion, I think the thing we're most concerned with here is the salt contamination of drinking water supplies, but it can also corrode subsurface infrastructure. The water table rise, just the fresh water table, can flood septic systems and cause them to fail, and can also saturate other subsurface infrastructure like roadbeds and foundations. And then we know the effects of land inundation, coastal flooding and erosion, and also salt contamination of drinking water supplies if in a storm, salt water is pushed up over a freshwater aquifer. So I don't think I really have time to go into the Monhegan example unless folks are unfamiliar with it and we want to talk about it later. But they did a program that was funded by the Coastal Communities Grant program a few years ago that I was partially involved with, that looked at changing their water supply from the shallow wells near the coast to a groundwater, to a bedrock groundwater well. But I think it's probably time to go to questions now. So.
Thank you, Ryan. You did an admirable job with a short period of time. Maybe we'll have to call you back at some point for a longer presentation. And thank you to all of our presenters. And I'll turn it over to Gabe for Q&A.
Great, thank you so much, and I'll echo the thank you. Great to hear from our communities, and Ryan, thank you so much. It was a very challenging job to put all of that information into such a succinct presentation. And yes, certainly if folks have are curious about the Monhegan story, we can ask Ryan to share a little bit about that. But let's first go to the questions that we've already received in the chat. If folks want to put additional questions in the chat now, that would be great, but we'll do the written questions first. And then if we have time, we'll just ask people to come off of mute and share their questions verbally, if that's your preference, rather than putting things in the chat. So just wanted to start. Karen was first on the Q&A in the chat. So asking a question to Carol, are there characteristics shared by the 5 areas with saltwater intrusion on Shebig, like distance from the shore, depth of wells?
They're all relatively close to the shore. So that is usually a common characteristics, but not always. These are all bedrock wells that are that have salt water, and to varying degrees depending on the time of year and their location. And one of the things is, in the summertime, we tend to have a lot more, like the other communities like Long Island and Westport, we have our highest population during the low recharge period that Ryan just mentioned. So the lowest water levels, but the most people withdrawing water. So we kind of have a seasonal issue with saltwater intrusion where it can be more severe in the summertime. And in terms of well depth, the deeper you go, the better chance you have of running into a problem, sort of generally, but it's very site specific. So
that's great. Thanks, Carol. And then I just wanted to jump to a question that Jared asked for Ryan. Ryan, can you answer this? I'm not sure you know the answer, but of the wells in Maine, do you have an idea of how many are coastal and at risk of increasing salination?
So one thing we don't have is a great handle on how much saltwater intrusion is happening, which is what makes these kind of projects at the town level so valuable. So we know that saltwater intrusion is happening. We know it's happened for a long time, but we don't have a great idea of the full extent along the whole coast of Maine. And so it's hard to say how many wells are really at risk of saltwater intrusion. That's something we want to work on, both collecting more information about existing saltwater intrusion and also doing modeling studies to kind of get a handle on, although it's very site specific, to kind of get some basic guidelines for what kind of wells are most at risk. So as Carol mentioned, it's definitely wells that are closer to the ocean are more at risk, wells that are deeper, and ones that are at lower elevation as well, and have like a lower slope up from the ocean. So we know that those are factors that impact how vulnerable a well is, but we don't have a great count of how many wells are vulnerable.
Do you have a way, Ryan, or are you like taking information that these individual municipalities, municipal studies are the data they're collecting, and are you being able to access that information and collect that data?
Yes. So some of the historic studies that Carol earlier mentioned that are from the 80s and 90s, we have our hands on that information. New information, we are trying to build a database right now. So that's kind of one of our projects for 2024. And so there's another hydrogeologist in our office, Jesse Meeks, who is actively working on collecting that data to have some kind of a database. It might not be publicly accessible because there's so much kind of privacy concerns about the data with people's, home wells. But we're trying to gather as much of that information as we can. Yeah, so if towns, know that they have a small database of wells, we would love to, we know about some of them that are out there, but we'd love to know about them, so please let us know.
That's great.
If you can share your data with us.
Yeah, share your water study information.
Yes.
So I'm keeping track of the time because I know we do want to stop just shortly before 1 in case there's folks that need to jump off. I know Chloe wanted to be able to share some information before we close out, but I also just wanted to address a quick question. Pat, you had asked for some data around PFAS contamination of groundwater, and obviously we didn't get into the whole PFAS conversation today. I'm just going to put the Department of Agriculture, Conservation, and Forestry link to the PFAS page in the chat, but maybe if you're able to stay on, after perhaps Ryan or someone else on the call would have some more information about the specific data points that you were looking for. And then in the last few minutes that we have before I turn it back over to Chloe, or I should say last couple of minutes that we have, maybe 3 minutes, I wanted to hand it back to Carol, if you would, because there were a couple of questions, people really curious. You had mentioned like actions and strategies to protect sole source groundwater resources, and folks were just interested in learning more from you about what some of those might be.
Yeah, so the first step is inventorying your town's resources and understanding where your problems occur. And that's what these 3 towns are doing. Chesapeake is a little bit further down the track because we've done this in the past, but that's really the primary focus. And once you know where you have particularly saltwater intrusion issues, you can look to different strategies to help minimize making them worse. So basically communities in the Pacific Northwest have actually developed zoning for saltwater intrusion related issues, permitting requirements for new water supplies, permitting for new wells, and they have a very extensive monitoring system in their aquifer. So a lot of these communities have similar geology actually to some of the northeastern sites, but they have a lot less precipitation. So they're even more vulnerable than we are here in the Northeast. So sort of a whole overlay of zoning and kind of permitting and hydrogeologic assessments for any kind of significant developments. Sort of similar and analog to say maybe how we might deal with a subdivision application and the water supply concerns with those. Then I know the state of New Hampshire is looking or has proposed and are considering this concept of sort of a groundwater rise zone overlay. So think of it like an overlay zone in your shoreline zoning where you have identified an area that's susceptible. Typically that has to be done based on some kind of groundwater modeling, which is a very complex and generally expensive step to take. But I think Ryan, that's what Ryan just mentioned, is sort of the state has an interest in looking at that. But from these groundwater rise zones, local communities can decide what kind, so they're identifying basically vulnerable, susceptible areas, and then you can kind of fashion the restrictions or hoops that people have to jump through based on what those particular vulnerabilities might be. If it's groundwater rise and inundation of septic tanks, it might be prohibitions on certain septic tanks below a certain elevation. If it's saltwater intrusion, then it might be people doing tests to make sure a new well doesn't make the problem worse. And typically with saltwater intrusion, additional wells can interact and actually so the more wells you have in the same sort of localized area, that can make the problem worse. And one thing, the reason this is often done on a local level is because unlike public water supplies, private wells really don't have a regulatory program. There are, requirements for how the wells are drilled and constructed that the state requires. But in terms of where you put a well and, except for some very minimal restrictions, there isn't really a program that covers private wells, very well in the state level or at the federal level. So that's why local communities are sometimes the best place to try to implement those strategies, at least at the moment.
Thank you. That again was a succinct, very well done, succinct overview. I'm sure we could talk a long time about that. And so I'm going to turn it over to Chloe real quick for folks who have to jump off. She's just going to close us out, and then we'll be on again for 15 minutes longer if folks want to continue the conversation. Thanks, Chloe.
Thanks, Gabe, and thank you to all of our speakers and for everyone joining us here today. Before you hop off, we just wanted to let you know that we do have a date in about a month from now for the second part of this topic. We're gonna make it a little bit longer to create some more time for conversation and discussion. So please do join us on Thursday, February 22nd, starting at noon, going for an hour and a half to focus more on how to address these challenges and specifically funding and technical assistance available for both kind of municipal planning and assessments that we've heard about already today, and also some resources, technical assistance, and funding for private well homeowners. So we'll have some speakers from the Maine Drinking Water Program, from RCAP Solutions, which is a regional nonprofit, and some more community perspectives. And the registration link should also be in our chat momentarily. So I encourage you to sign up, get that on your calendar, and we hope to see you on the 22nd. Thank you so much for joining, and we'll hang around if you want to discuss further or enjoy the rest of your day. Thanks.
Thanks, Chloe. Yeah, and thank you, folks who have to jump off. We appreciate you joining us. And just got a question from Marianne. Will the meeting recording and slides be available? Yes, and I believe we'll be sending everything out to everyone who registered, correct?
Correct.
And then it'll be made available, I think, on Casco Bay. Will it be on your website? Yep. Okay, very good. Yeah, we'll make sure that gets out to you. And then Ryan, we had a question asking if you could put the sea level rise graph up on the screen again. Great. Thank you so much. Tom, I wasn't sure you had asked that question. Did you have a particular question regarding what you saw on the sea level rise graph, or you just were hoping to see that again? Tom may have jumped
Yeah,
off.
I didn't talk very
Oh,
much
okay,
about
yeah.
this slide, but it shows a steady increase in sea level of about 2 millimeters per year since 1910. And that is continuing as well.
Thanks, Ryan. Appreciate that. I did just also want to acknowledge that we had a question from, let's see, let me just make sure. Yeah, from Richard, who was asking about grant sources for doing well studies. And it was mentioned that we will be talking in the next workshop about those various funding opportunities. I think the one that Ryan did mention that Monhegan had taken advantage of was the Coastal Community Grant. And we can certainly drop a link for that in the chat. That period isn't open yet, but it will be very soon, that grant funding opportunity. And then the communities that spoke today were taking advantage of a community action grant through the Community Resilience Partnership. And we can put a link for the Community Resilience Partnership in the chat as well, so folks can see at least those two funding opportunities. I wanted to just see if there was any more questions that folks have. Excuse me, I have to cough real quick. Thank you. If folks wanted to come off of mute and just ask questions, if you have any, or you may feel free to put them in the chat.
Hey, Gabe, it's Bill Bowe. I got a quick question.
Hi, Bill, go ahead.
Hey, I missed the middle third, so my apologies if this has been asked and answered, but in order to do a well inventory, are there any generic resources out there at the state level? I can look in the community. And then secondly, has anybody put together sort of database templates that would allow us to, just sort of use other people's work to figure that out, location, lat long, depth, aquifer, blah, blah, blah. I mean, I can do it from scratch, but I'd rather cheat.
Carol, it looks like you're ready to address that one.
That's a question that's near and dear to my heart. So I've been working with Jessica, Brian's colleague, on just that issue. And so I think our goal is to try to utilize these data sets from towns. And I think we are working on coming up with sort of a uniform template for a database structure so that the data can be easily incorporated into the town data set and used on a GIS system, either through a town interface or through the state interface. And as Ryan said, the water quality data might be a little bit different. It might have to be aggregated because there are privacy concerns, but the well construction data could be, it's public. And so stay tuned, and I hope that we will have sort of a format to provide to you for that. And as far as what we call it is, say, a well inventory survey form, you can do them in paper form or online. There's a lot of examples out there, which we're happy to share. The town of Westport Island just did one. Shabik did another one. So those examples are out there. There's some basic information you should definitely collect on well construction information, location, but then there might be specialized information for your community. So we can share those resources.
And is it fair to assume that, I know many states have fairly widespread databases based on my career, but I don't know Maine. So as far as the state inventory, there's probably very little, or?
No, the state has actually a very extensive well database that's available online through the Maine Geological Survey, through Ryan's office. But we have found, at least in the communities I've worked in, that it's not complete. And so we often are supplementing that information. And sometimes, because some of the data is rather old, we are sometimes correcting the locational information.
Okay, thank you.
Thanks, Bill. Thanks, Carol. Other questions that folks have, or things that they were hoping to hear a little bit more about that any one of the presenters was sharing on? Just come right off of mute if you would like to ask. Don't be shy.
Gabe, there was a question, I don't think we've covered it, from Jared, but it looks like he may be off now, but he had a question for Ryan. Of all the wells in Maine, how many are coastal and at risk of increasing salinization?
Yeah, I believe
Did you cover
Ryan
that?
did answer that.
Okay,
Yeah,
sorry
yeah,
about that.
we got that one. Yeah, no, thank you.
So maybe one more topic or area for next time would be around pollution sources, especially with what we just heard on groundwater pollution with sea level rise and more frequent storms. Just maybe non-traditional pollution sources that we might not think about addressing to mitigate risk might be something to get us informed on.
Yeah, thank you, Janice. Oh, Ryan, did you want to respond?
Yeah, I think I would have talked about that a little more at the very end of my talk, as kind of other concerns for water quality. And I think I mentioned the de-icing salts. So I think transportation, it's basically two categories, transportation and human development. So like kind of sprawl and residential development impacts groundwater quality through lawn pesticides and nutrients. So people are spraying for ticks and mosquitoes a lot more than they used to. Fuel spills, so like, moving away from liquid fuels. That's, been a long standing concern. septic systems, and then the transportation around de-icing salts and petroleum products again. Metals and microplastics are, kind of emerging things of concern. So we're kind of moving away from the era of point source problems. We've cleaned up a lot of industrial discharges. Sewer treatment plants have been upgraded, over the last 40 years. And I think it's these non-point source, so, kind of dispersed pollution across the landscape that are the current concern with the water quality of groundwater.
Thank you.
Yeah, thanks, Ryan, and thank you, Janice. And I'm sure Victoria and Chloe are also noting maybe this is yet another workshop topic, since there's a lot to cover in that area. But yeah, thank you. Any other questions or comments, things you would like to hear more about?
I'll go again.
Please do.
Is there a list of laboratory resources that we can get our hands on as far as where you should send your samples for analysis within the state? I mean, I could smile and dial through, any web search, but if we've got a list of them, that'd be great.
Carol, did you want to respond?
Yeah, the state CDC website has a list of Maine certified labs.
Thank you.
Thanks, Carol.
Yeah,
And
if you go
Ryan?
to the website wellwater.maine.gov, that takes you. That's kind of a shortcut to the drinking water program. There's a Maine state laboratory that can do water testing. There's also private labs around the state, and there's a list on that website.
Yeah, that's the list I'm looking for. So thank you.
Mhm.
Thanks, Ryan. Thanks, Carol. Tom, go ahead.
For future potential topics, a couple areas that we're concerned with down in Biddeford. Number one, we're an MS4 community, so the non-traditional pollution sources and how they're impacting water quality, as well as any tips on how to control those. I mean, the residential developments have, their stormwater management systems, but the non-point source, and I hate to pick on agriculture, and I grew up on a big farm, so that's one of the areas that seem to be lagging the furthest behind. I know there's been a lot of work by soil conservation to address some of those issues with increased buffers and fencing off streams and whatever from cattle. The other one that we're facing, again, as a urbanized area is, and it particularly intrigued me, that the accumulation and then the washing out of pollutants out of leach fields down in our Biddeford Pool area. I would like to be able to see if there's a correlation between when we have particularly high hits of various pollutants in the pool. DMR tests it at least twice a year, and that compared with maybe periods of drought, and then rainfall after that, whether there is any correlation, because I know that's a concern that both codes and us in engineering have. That, how do you deal with that? Great, thanks.
Thanks, Tom. Thanks for bringing that. I don't know if there's like any kind of response on your end, Ryan, but seems like there'd be a lot that would be another in-depth topic.
Yeah, I mean, I think Tom's intuition is probably correct. I don't have that data on hand, but I think that, like, bacterial closures, and this is a little bit out of my area of expertise, but I think bacterial closures are very well correlated with high rainfall runoff events. And my guess is that they are worse after periods of drought, but I don't have that information. So I think that would be something great to hear from DMR or DEP, at the state level about that. So yeah, I agree.
Great. Well, we're noting that as well. Thank you for bringing that, Tom. I'm looking at the time and seeing that we're just about at the point where we wanted to close out. So if there's any last quick question or comment, now would be the time.
One quick thing then, Gabe.
Very quick, yes.
So we're in the process, as you know, of potentially building our own wastewater treatment plant. We'll probably end up using membrane bioreactors, so the subsequent water that's coming out of it is, I won't call it drinkable, but it'll essentially be in that state. Do we have any resources within the state on beneficial reuse concepts in what we're doing? Is that something that's starting to bubble up in Maine, or is that still a California thing?
I can try to answer that a little bit. I don't, again, I don't know that much about it, but I think beneficial reuse of wastewater is I would say is not something that's being talked about very much in Maine.
Okay.
Just because in general, we have enough water. Yeah. So it's, that's kind of a Rocky Mountain and Western kind of thing. So I haven't heard much talk about moving in that direction, but it doesn't mean that it couldn't be done in certain locations. Where water, some coastal communities that do have real problems with their water sources.
All right, thank you.
Thanks, Ryan. Thanks, Bill. I'm just gonna turn it back to Chloe to close us out for the final time. Thanks, everyone.
Thanks, Gabe. Well, we're right on time, so we'll let you go and get to lunch if you didn't already, but please do register for the program. We'll also include that link when we send a follow-up email to all of you and all other registrants with the recordings and the slides. So with that, thank you again, Ryan, Carol, Janice, Richard, and hope to see you soon.